smart folks out there that are tuning into my show today. I got a real exciting one for you today. This is my thoughts on how we should terraform Mars. Now Mars, the first thing we got to deal with is it's really, really cold. So what we want to do is we want to change the surface temperature by changing the surface color. Now we're going to change it from like kind of red and the beige color to black. You want to be as black as you can. So we're going to be black on the planet. The entire surface we're going to change to a black color. And what that's going to do is it's going to raise the surface temperature as much as 30 degrees Fahrenheit, which is a lot. Now your planetary temperature, atmospheric temperature should raise at least 3 degrees C. Almost within, as soon as the dust settles, you're going to have that. So livable within years. Higher temperatures are good because we want to be able to have more energy there, and of course it's going to be captured by the CO2 atmosphere. The CO2 envelope holds in the heat. Now how are we going to do this? Well, I want to use carbonaceous asteroids and metal-rich asteroids, a combination of both, to create two belt zones around the planet. And you know, the polar areas we don't even really need to deal with as much, but at the same time we still need to coat them. Now these layers here that you see, those are left over from the volcanoes that have been constantly erupting for, well, they erupted for a long time and then they stopped for a while. They're probably stopped by now. But the thing is these layers are ash layers and they cover up the minerals. So all your really valuable minerals, the things that you're going to want anyways, are like a kilometer down anyway. So you just, and if you look at the surface strata, the layer deposition on Mars, it's like wind strata deposition. There's some water flow. Those have been from previous asteroids, water-rich asteroids that have hit. And then of course the water drained out and then it probably flowed maybe like a glacier. They're talking about water, but it's probably more like glacial flow where you get the ice that moves. Anyways, so my idea was we have this massive asteroid belt out there, and it's really, really difficult to mine the asteroid belt because the asteroids, when you move them around, they get into the way of each other. So you have to be real careful about how you extract. It's almost going to be like that board game Operation. You're going to have to like operate on the asteroid belt. And what we're looking for are very specific size and composition asteroids. So we're going to have to probably use drones, little tiny drones. They go out there and cherry pick and guide these specific asteroids out of the asteroid belt. There's two types of asteroids we need. We need C-type asteroids, and we need the iron asteroids, the metal-rich asteroids, both of which. Now, you're going to lay them down across these two zones, here and here. And of course, in the beginning, you can also take the carbonaceous asteroids and you can put them at a degree angle, adjust your angle of entry for dispersion, pattern, and penetration. So there's two things you have to do. First, you're going to have to paint. I see a red planet and I want to paint it black. That should be the name of this video because that's exactly what we're going to do. And maybe we'll use that little thing. Anyways, so if you size your asteroid correctly, you're going to be able to create these neat little crater mine habitats. And this is going to be really cool because the C-type asteroids, they contain all those really neat things like water and things. And you're going to have a penetration that's going to go down into the dirt, and you're going to end up with a domable mine area. And it's, because you have low atmospheric pressure out here, and you have oxygen and water inside these carbonaceous asteroids that's going to want to leak out, you can trap it, and you can use like a gate that kind of controls how much is in here, and it's going to be pretty straightforward. I mean, right when it first hits, it's probably going to melt and flow out, and then it's going to freeze solid, and then it's going to outgas. Now, this is going to give you a source of oxygen that's going to last for hundreds of years. Hundreds of years. And I realize that they've got, CO2 converters where they can convert it and crack it and get the oxygen out. That's cool too, but I mean, this will give you a source of water as well, which is not something you can get from CO2. Well, I guess you could with hydrogen, but then again, once again, you need something. So that's the thing. Mars is very, very needy, and you need to put a source of elements there that they can draw off of, the takers, the people that process things, the people that take things and turn them into something else. They need a source of everything. They need water, they need iron, they need all that stuff. So what we're going to do is we're going to create two mountain ranges, here and here, and we're going to be very selective about which asteroids we use. So it's going to be like, this is a valley, and we're going to build that up outward. So you're going to have peaks here and here, and it goes down into a valley, and then down into these craters here. Now, either before or after, thereabouts, I want to do like a Dyson belt city, and where you have tunnels. Basically, you lay down your tunnel boring machines, and you literally just go out across the planet and create a belt. So you have these basically hyperloops that go around the belt, the equatorial zone of Mars, and then they have access to any point on the planet. Now, what's nice about these crater mine habitats is these are sources of oxygen. They're giant sources of oxygen. The thing about the mountains is they will hold two things. They will add iron, which will create low-intensity magnetic fields along the surface, which will help to hold in the oxygen. You'll end up with this belt of oxygen that begins circulating across here, and it'll be mixed with CO2, but you'll have an oxygen content. If you drop enough of these C-type asteroids down into the valley here, you will have water, you will have ice, you will have precious minerals, gold, and all that stuff. And also, you want to drop these C-type asteroids and the iron asteroids. You want to size them so that you can scale this up. You can scale it up and create a mountain range. You can literally go all the way up into here. You can literally go up into here because there's no plate tectonics to worry about. There's no oceans yet, but we could eventually add one here. And it's just one of those things where you get enough water on there and eventually it's going to start flowing and moving. But you also have to change the surface temperature and you have to change the surface pH. Right now the surface pH is so bad that it kind of dissolves aluminum, which is bad because aluminum is a very important aerospace material. So basically all of your aluminum parts that are exposed to the sand right now and the dust storms that last like a year or two, those are going to dissolve and you don't want to have that happen. So you change the black surface color, you're going to need a base, and you're also going to need orbital laser platforms. Now I think orbital laser platforms are the best way to go because the orbital laser platforms allow you to use laser-induced steering jets on the asteroids that are incoming. So you're going to need a bunch of, or at least a few, orbital laser platforms, maybe 12 at least, so you get a hex pattern on the top and the bottom of the planet so you can guide these things in. And it'll also allow for, if you're having a real problem with an asteroid, I mean, honestly, it's the best option. As for the solar power electromagnetic launcher, you don't necessarily have to use that. You could use micro drones that could be serviced from a base. So the big important thing is you're going to need an orbital base. Now, what we know about orbital bases from our own orbital base that we have currently up there, the space station, it's an international project. It's huge. It's really kind of difficult, but this is going to be a different type of base. And for the most part, almost all of this can be automated. I would say sending humans to Mars right now is a huge mistake. From my calculations, if you send humans to Mars right now, they will die quickly, and that's a problem. If you send them out in the asteroid belt, you start screwing around with the asteroids. Okay, let's say I move an asteroid wrong and it moves into the path of another asteroid. If you've ever seen the asteroid simulation, how the asteroids in the asteroid belt move, if you move an asteroid into the path of another asteroid, they're gonna collide, and then you're gonna have this big area that becomes unminable, unextractable for a long period of time, if not a lifetime, human lifetime, because you don't have access to that area because you have all of these new trajectories and all these little tiny micrometeorites moving every which way. So you want to be very, very careful about extracting asteroids from the asteroid belt so you don't move an asteroid into the path of another orbiting asteroid or another orbiting body. Now, these mountains, you're going to grow your own planet. You're going to drop these iron mountain asteroids down on top of this thing. And you need to watch your mass, of course, your overall mass. You need to watch the position of Mars as well, because as it becomes more massive, it's going to be drawn inward towards the sun, which you don't want. Not too far, but that might solve a few other problems too, because you could get it closer to Earth, therefore your trips back and forth to Mars would be shorter. So you could create a true exchange between Mars and Earth by bringing them closer together, because you increase Mars's rest mass. You are also going to give it a magnetosphere. Well, a surface magnetosphere, and that's really all you need. You just need the gases to cling to the surface. You don't have enough gravity to really hold them there, so what you really want is just a valley where the gases are concentrated for hundreds of years. And that's pretty much it. I mean, that's how you terraform Mars. It's the easiest, fastest way that I can think of to do it. Also, I've envisioned the other projections of what I've seen from the proposed the technology that's been presented so far from like the Boring Company and all these other companies, corporations that want to go there. And to me, it looks like it's going to be a fail. If you send humans right now, it's going to be a fail. You need to prep Mars, you need to enrich the surface, you need to prepare it for the arrival of humans, and it has to have an abundance, an overabundance. It has to have thousands of percents above what is needed to survive there, or the humans will die. Now, the reason why is because as time goes on, the political climate here on Earth is going to change. So if you try to do this umbilical population and stocking of Mars, it will fail, because the political market and the economics here on Earth will change in response to Martians being on Mars. Just the investment, all the bubbles are going to change. And that leads to political unrest and civil unrest, and then eventually you get wars, and then suddenly you have a bunch of stranded colonists on Mars that you're only going to have like one chance to get them off of there. And who knows when that type of civil unrest and economic unrest, who knows, you could have a massive nuclear war, and then everybody on the planet is toast, and you're not going to have the ability to go there anymore. So you might have like one last ditch effort to get them off the planet. Instead of doing that, let's create a mineral rich place where you can stage asteroid mining safely. You can't mine asteroids safely out in the asteroid belt. If you start taking an asteroid and you put like little jets on it, you start moving it around, I mean, just the simple process of mining that thing is going to move its orbit, and if you aren't in a process of removing that asteroid from the belt, it's going to end up colliding with another asteroid, and it's going to make a big mess. People are going to die. So this is a terrible, terrible, terrible place to be when you talk about humans. Don't put people in the asteroid belt. Just don't. They'll die. Don't put people on Mars until you've prepared it for humans' arrival, or they will die. It's just straight up. I mean, it's going to be a terrible idea. But let's look at what you could do. You know, you've probably all been looking at this while I've been talking. So you get these carbonaceous asteroids that have all these minerals, and you can dome them, and then you can take those domes and all of the output from them, and you can extract the gases, and you can pipe it off into the Dyson Belt City. The tunnels, I think, are going to be hyperloop. I mean, it's going to be pretty simple when you look at what you have to drill through. It looks like clay, just clay and some light mineral bearing rock. So I think the tunnels that go around the equator, Mars isn't as big as Earth, and there's no ocean, so you can literally create a belt all the way around it of hyperloop tunnels. And since you have way lower atmospheric pressure, you can get away with that too. It'd be pretty easy to maintain. I think that you should have inner belts. Initially the tubes. After you prep the surface, and you talk about, okay, well, you're going to have all this dust and stuff blowing around, but at the same time, it's going to settle. Just like anything, you have a atmosphere, and you're adding more atmosphere, and you're adding micromagnetic fields. You're adding essentially traps for that dust, so it doesn't just blow across the surface. You're going to create a situation where you have craters. You're going to have mountains. I mean, you're literally bringing minerals to here to create overlapping. If you ever dealt with like mineral deposition, crystal deposition, it stacks up eventually. So it's going to take a while, but it's possible. And I think we can do it with microdrones. Similar to the Starlight satellites, we can send microdrones out there with mini hydrogen thrusters. I was thinking actually using water, maybe as a propellant in space. Water expands a lot when you heat it up, so I think water is a great idea. And of course, if we're mining the asteroids for water as well as other things, it'll give us an unlimited supply. You need to have, you need to have an unlimited supply of stuff, lots of stuff, iron you need. And then of course there's the precious minerals that you're going to find in there. So as you mine these things, now mining is a very difficult thing too. I wanted to touch base on that just for a second and let you know that you're not going to probably just want to send your smartest people to Mars because of the death thing, but also because mining is difficult work. If you talk to any miner who's been mining their whole life, generations of miners, they are some of the gruffest, toughest individuals you'll ever meet. And you need to take care to think, okay, I can't just send a bunch of book nerds up there, because book nerds are not rough and tough for the most part. They're brains. They're not bodies. So you're gonna need really, really strong people and have that willpower to succeed and have that background, that knowledge to do it. Now eventually you could probably just do this with robots and you wouldn't even need to send humans there at all. It's almost a really good idea when you think about it. I don't think we need to send humans there initially, but you do need somebody here at the laser base controlling that, and so you can guide these asteroids in. But I haven't seen any planetary terraforming projects from anybody else that would actually work. This would work. This would work. You change the surface temperature, you change the atmospheric composition, you introduce easily accessible minerals and a process to continually extract and add more minerals to the surface of Mars. Use Mars as a mining base. Now, as you add mass to Mars over the generations, it will bring Mars into a closer orbit with Earth, which will make trade exchange between Earth and Mars much easier and faster, and you'll end up with a free trade between the two planets, and you'll have the situation unlike Earth, where all the minerals are all tapped out, and all of the families that control all of the minerals and all the corporations and countries that control all the minerals are no longer monopolized. It's not like they have the ultimate control of all these minerals, whereas you now have a new source of minerals if you go this direction. And the first time you pull a gold bar the size of a school bus off of one of these things, or the size of a tree, just literally imagine a sliver of gold this big. You're going to be able to take these impact craters and be able to go right into them. And what's really nice about having more oxygen on the surface of Mars and trapped in a valley-like structure, or where you have mountains on either side, is the dust will be, of course, gathered into these valleys, and so it's going to settle the dust faster. It's also going to create a situation where you could wear a concentrator. Instead of carrying big giant tanks on you, just have a concentrator in smaller tanks, and you'd be able to literally just scrub the dust out of the air, concentrate it a little bit, and now you have enough O2 to breathe. That's what we really need, is O2. You could probably breathe O2 as long as you had the inert gas, which is what we have here. So that's pretty much it. Other than creating the habitats and the Dyson belt here, the tunnels, I just the Iron Mountains, changing the surface temperature, putting a base. You're going to need a base. I think this is going to be one of the main things you have to do, is have a base that orbits Mars and allows for these. And you might, the orbital base. Honestly, why don't we start thinking about the moon, Mars's moon? Put the orbital base on Mars's moon. Don't have a free-floating thing. That you don't really need that. You need structure. You need some place where you can lay down your roots. And I think having a base on the moon is going to be a really, really good idea, because then you're not just out in the open. Now, admittedly, you might want to go into the moon and put the base on the inside of the moon. That way you have protection from this whole process here, and it would allow for an orbital base around Mars where you can terraform it over a period of, I don't know, you're going to have to move these things around. How long does it take to move an asteroid into orbit? And even if you don't use the orbital laser platforms, if you use drones to guide these things in using math to strike the surface and create these craters and deposit minerals and elements onto the surface of Mars that are useful to us, useful to humans. And the goal is to use this low oxygen atmosphere to create ship hulls. Mild steel, ultra high vacuum ship hulls in low gravity that can be launched into orbit easily. If you're dealing with the mild steel, you could technically use an electromagnetic launcher, launch up into space. And it also gives you access to all these minerals that are going to come out of these asteroids. And we can be picky. We can take spectrographic analysis. We can use radar up close. We can use ultrasound. We can use all kinds of imaging technology to cherry pick these asteroids before we send them down to Mars to be extracted. Could you put an extraction base on the moon? Yeah, you could. But I think the base on the moon should be more for defense. You're going to have to basically set up a atmospheric defense system that can intercede, maybe send out brilliant pebbles to intercede on an emergency basis, but also control the orbital laser platforms. I think the orbital laser platforms are going to be super, super important to put in immediately before this process. Before the process, really gets going, you're going to need orbital laser platforms that you can target incoming asteroids, carbonaceous and iron, to create microjets and use the material of the asteroids themselves to redirect their position as they come in. And that's going to be probably your most effective way. You can use drones to launch them. Drone swarms and hive ships that power and refuel the drones automatically, can be controlled from either the moon base on Mars or from a floating base that we tether to the moon. And that's, you know, I mean, do we really want to be in orbit around Mars on a free floating base? And I think the answer will be no. You want to have the structure and the protection of Mars's moon surrounding your facility, and that's why you're going to land on Mars. You're going to Mars's moon. You're going to drill into Mars's moon, and you're going to hollow it out on the inside and create a moon base there, where you have a physical structure, an impact zone around your base, so you don't just lose that base. I mean, right now it'll also allow you to give you. I mean, it just, if you're on one of the moons, if you pick a moon, you know, you got two of them there. You could have two different types of bases there too. You could probably even put the lasers on the moons. But I think that having orbital laser platforms around Mars to guide these things in is going to be your best bet. Other than that, I think long term, Mars, when I look at the equation of the solar system versus what the universe wants from us to do with Mars, I would say that it is to use it as a mining base to mine the asteroids. But we're going to have to be super careful. I mean, it allows some play, but we're going to have to still be super careful. And just its position and proximity to the asteroid belt, our level of technology, our level of AI, our level of robotics, our level of microspace travel, we are in a position right now to begin mining the asteroid belt and begin reaping those benefits. But at the same time, we're going to have to create a biosphere. This would be a massive shipbuilding facility. That's what Mars would end up being, as a giant shipbuilding facility where you would have zero or very, very low oxygen steels and metals, and those types of steels and metals and things like that are going to be very valuable. And you can use an electromagnetic launcher to launch them off the planet, and now you can guide them back to Earth. And of course, Earth, you know, any resources that increase. Okay, the price of steel is going to go down for a little while. That doesn't matter. Now you're going to have this excess of steel. Now you can create all these new things that all the projects were held up because of the cost. Now as we go forward, everything's costing more. We need a source of materials, of ship hulls. I mean, imagine you can have these giant ship hulls. Now you can have inner solar system spaceships that can be built, which will take you further out, will take you to Europa, which will take you to Titan. So eventually, one of our main goals as a species, it will be to get to Titan and begin harvesting the hydrocarbons that are there, the rich hydrocarbon oceans, because we will need those. As a species, maybe in the next 50 to 100 years, we're going to have to seriously think about going to Titan, and we're going to need large, mild steel, ultra-high vacuum resistant spaceship hulls that will allow us to take large volumes of liquid, hydrocarbon liquid, and bring them back into the inner solar system safely. And of course, the technology to get from here to there, it starts by turning Mars into a giant shipyard. And you're going to have to do that by populating the planet with mineral deposits that are on the surface that you can mine, and setting up a system where, you know, semi-automated, but at the same time, you know, run by pretty much the roughest, toughest individuals that are being guided from above, from the base. And this is where you're going to put your super smart wizards, the ones that are keyboard wizards, coding wizards, you know, space knowledge wizards, you know, up there at the in the moon base. And then down here, this is construction, this is mining, this is crushing, this is smelting, this is everything that you need to make big giant ship hulls and the actual production of said ship hulls. So I think these things right here are ideal because you're going to have increased oxygen inside the crater mining habitats right there. So you're going to have really, really cool place to build stuff if you want to, and to extract minerals. I think that's probably the best bet. And of course, you know, you've got a constant influx. Like, you can take all the people that are up in this northern latitude, move them all into the southern latitude, and just bombard this area. And you could get really, really good at it to where, you know, you're hitting specific valleys. Like after your Iron Mountains are in, you can take and start filling the valleys with these crater habitats, and you're going to have Iron Mountains, which you're basically going to be surrounded by artificial magnetic fields from the impacted meteors, because they have a big magnetic field, and the bigger they are, the bigger the magnetic field. So Mars doesn't necessarily need a magnetic field. As a matter of fact, in this case, it would probably be better if it didn't. That way we can create these iron mountains with micromagnetic fields and these crater mine habitats. So if you moved everybody out of the northern latitudes here, put them in the southern latitudes, and then restocked this area here with iron meteorites that you've chosen from a swarm, and you could probably take the asteroids and move them into a holding area, like a holding pen, almost like you're doing cattle. You move them out, you put them in a holding area, and now they're still in orbit around the sun. You're just moving them, their position out, and I think that then you can begin launching them, and you could extract them. I think the best thing to do would be go through the entire asteroid belt, begin cataloging it to find the right asteroids after we start the bombardment process, to determine the best way to build this type of structure. So this is a full-blown how do we terraform Mars using hundreds of trillions of tons of material. So, or trillions upon trillions. You know, there's no limit except for, like I said, if you got to watch your mass of Mars so you don't end up with an elliptical orbit. There's some things you're going to have to do carefully, and that's where your super brains come in. You're going to have to use artificial intelligence. We're going to have to use massive simulation and modeling for every single piece on where it's going to land. It's going to be like a giant Tetris puzzle. So each piece comes down. Where does it go? It has this mass. Where's the best place to land it on to maintain equilibrium forces on the orbital structure, both the revolutions around the sun, and also the orbit and the actual rotations of the planet itself. So I think that's two things to really think about from a simulation standpoint. But you know, you can have all of these chosen asteroids, bring them in with drones in closer to the path of Mars, and then start hucking them. You could actually have a processor goes through there, and micro drones from the hive bring it into the processor, and you start shooting them at Mars after you get this process in place, and then of course guide those in on a trajectory that soft lands them in such a way that you end up with these great crater mining habitats. And it looks like you're probably going to want to start with the iron ones, to be honest. You're going to want to start with the iron mountains. That gives you an immediate product, because those iron meteorites also contain precious metals. So now that we have a ruthenium problem right here, we have these platinum derivatives that platinum group metals that we have they're very rare, but we need them for industry. We need them for catalytic converters. We need them for advanced sciences here on Earth. And to get them, well, we're going to have to process a lot. And we can choose those particular asteroids. Why don't we choose some things that are going to help out the industry and have the greatest dollar value here on Earth? Your steels, your irons, your golds, your silvers, your coppers, your tungstens, all your things that we use in industry here that we're running short of supply of. And you're going to get some gemstones in there too, but I mean, honestly, we can synthetically grow the useful gemstones like sapphire way better than we can finding them out in the wild. I mean, the stuff that's in the wild is pretty inclusion ridden and not very useful for advanced scientific products. But yeah, we could have staging zones all around the orbit of Mars, and just push those into holding areas, and then when Mars comes around, we can go launch them, launch them, and we can have that going on. But this technology would have to be accepted by those bigwigs that realize that to really go after Mars, we're going to have to think about, okay, what do we do with this place? I mean, they're talking about all these cute little exploration things, but let's step aside and say, all right, as a species, what do we really need? We need an asteroid staging area that won't blow us up, because you have to be really careful out in the asteroid belt. If you get the wrong asteroid moving in the wrong direction, see, this is going to assist us too, because now we could technically have orbital laser platforms that go all the way around the orbit of Mars that we could launch and control. And that would help us with redirecting incoming threats to Earth. We'd be able to have an early warning system where we really see what they're going to do, all of the mathematics, all of the scanning systems to see said objects as they come in, and also a targeting system, laser targeting system. If not from Mars itself, you can have, positioned orbital laser platforms all the way around the asteroid belt. Just create a ring of them. And when you talk about spending money on stuff, from a money spent for return viewpoint, drones, even one asteroid of platinum derivative metals, even one asteroid of iron or steel or whatever, of nickel, is going to, yes, it would upset the market, but if you can mine that and bring those materials back to Earth, you're going to instantly fund the next series of platforms, the next expansion out here. You're going to have the materials. Like, for example, Elon, he wants to build his spaceships out of stainless steel. Okay, fine. What if he had an endless source of steel? An endless source of stainless steel. And it would be oxygen-free, which is something that's super, super important here on Earth, is creating these supermetals. Oxygen-free supermetals create some of the most radical oxygen-free copper, just oxygen-free. When you talk about the super radical stuff that's in the ultra highest scientific laboratory, it's oxygen-free. And that's when you start to see the really cool scientific instruments and most powerful magnets and things like that is when you have that kind of stuff. So Mars is going to provide those types of materials, which is going to be like top shelf materials. So now it's worth bringing it back to Earth because you're going to make money and you're going to have unlimited resources. Mining our moon is a super bad idea, by the way. Mining our moon, don't mess with the mass. Don't add mass to it. Don't take mass away. We're in a balance right now. If you look back in the history of Earth, the moon used to be a lot closer, and it had terrible issues. And since we're dealing with a gravity-locked object, we don't want to change the mass of the moon like at all. You just don't mess with it. Seriously, you don't want to mess with the mass of the moon. The mass of this moon here on Mars, nobody lives here. Nobody lives here, and by the time anybody is going to live here, the moons will have settled into their new orbits. It's going to be easy to adjust, and like I said, this will allow us to put an orbital laser platform ring between the orbit of Mars and the asteroid belt, so we'll be able to have an early detection system and a defense system to where we can use pulse lasers or continuous lasers to create induced steering jets on any incoming asteroid to guide that asteroid to a new trajectory, which is way better than the DART system ever thought about. Anyways. Ooh, out of breath. All right, so that's how we terraform Mars. Isn't it great? Where's my coffee? Thanks for tuning in today. I'm happy that I got all that out because I really wanted to talk about it today, and thank you so much for tuning in. If you haven't subscribed already, please do. And thumb me a like for the ones you like, and let me know in the comments below. There's moderation on my channel. I moderate all the comments because there's a lot of haters in this world. A lot of haters and a lot of people that just want to post ridiculous comments that are absolutely off subject. So as the admin for my site and my channel, that's just the way it goes. If you want to add something that's helpful, if you want to make a comment that's real, all the real comments get through. And all the ones that are hurtful or hateful, those don't make it to my channel. I don't allow those. So if you want to post a comment that's on subject and on point, if you want to flex your mental muscle on my chats there, please do. It's welcome. It really is. Anyways, I'm Zio205IQ. Thank you for tuning in today. I hope you like the video. I hope you like my new vest. Yeah, I like these in all my pockets. You're probably all, where'd you get that? Made in India, but it's pretty nice. I like it. I like coffee, and I like all you tuning in. So tune in again real soon. Today was how to terraform Mars the right way. And of course, hope you enjoyed it. Talk to you later.